Leader LT4670, true hybrid IP and SDI sync pulse generator. How can PTP be used as a reference source? With more and more broadcasters having to synchronize their SMPTE ST2110 broadcast infrastructures to existing IT infrastructures, Meinberg's IEEE 1588 Grandmaster with PTP version 2 time server appears to be the product of choice for broadcast IT departments. To synchronize the SMPTE ST2110 broadcast infrastructure, the Leader LT4670 can act as a PTP client and provide synchronized PTP and traditional analog, black and burst, tri-level sync, SD/HD, SDI black, and digital audio, AES and EBU references. The reference configuration menu is used to specify settings relating to the reference signal and the genlock operation. When the reference config menu is set to either PTP1, PTP2, or PTP1/2, the PTP mode should be set to follower. The LT4670 will lock to PTP1 reference, whilst PTP2 will be passive and ready to take over if PTP1 is lost. Now, one of the major concerns people have with using PTP as a reference is the accuracy of PTP from PTP client follower devices downstream. And here at Leader, we can demonstrate the accuracy of the LT4670 when it's in this mode using the diagram above. So now I'm going to hand over to my colleague Steve, who's going to walk you through this demonstration of the LT4670's accuracy when the reference source is PTP.
We are going to take a look at the 4670 being used as a PTP follower and how close to the originating PTP the timing is on its output. Here is a quick, simple drawing of what is going on. I have a grandmaster putting out domain 44 going to a PTP distribution switch. One leg of that switch with domain 44 is going directly to my LV5600 PTP analyzer waveform monitor. The second port is going to the 4670 to be used as a follower. It will recreate on port 2 of the PTP out of the 4670 a new domain 46, and we will compare the timing of these two outputs on the 5600. Here is a shot of the web page of the 4670 and its output. You can see down here the follower and the leader. And if we take a quick zoom in on that part of the page, you can see that one easy for the clock ID is on PTP1, the follower. That's going to be domain 44. And it is clock class 6. It is locked to GNSS, GPS. We will be creating on output 75 the new leader, which is on domain 46, which is also clock class 6, but it's coming off of the derived lock of PTP. In looking at the LV5600, looking at the 2-1 easy coming in and 7.5 coming in on port 2, we can see there network delay times are almost identical. So this is just normal everyday network delay. What we're interested in is looking at the time offset. And if you look at the time offset here, the time offset is less than 2.5. It's right around 2 microseconds of time offset between the originating domain 44 and domain 46 coming in. So the time offset is very, very minor. We can see all of the pertinent data about the T2 minus T1, T4 minus T3, our traffic coming in to calculate this, and then looking at the time offset. We can then also look at the info in more detail here and actually look at the origination times stamp here of 355, the origination timestamp of 356. So here's 359, 356, and 364. There's just about 2 to 4 nanoseconds of difference in the origination timestamps as they come in. This one is locked to GNSS. This is locked to PTP that was created off of this domain in the 4670. So its PTP follower is incredibly accurate, incredibly close to what the originating GPS coming in was. Thank you very much for your time.